Hello everybody and welcome back. We're going to continue on in this video the paper we've been doing for the last little bit, which is the 2013 Canadian Senior Mathematics Contest. That's the senior paper, not the intermediate. I tend to flub those two together. We're talking about the senior paper, that's grades 11 and 12. We're almost done all of Part A, which is just the final answer part. Pretty soon we'll be in Part B, which is the written portion. We'll have to justify our responses, but we're not quite there yet. So let's take a look at the last question in Part A. That's question number 6. It should be a challenging one. This is the senior paper after all, and this is the last of the final answer style questions. So, question 6. If P and Q are positive integers, max PQ is the maximum of P and Q, and min PQ is the minimum of P and Q. Okay, standard notation. But if you haven't seen it before, it's nice to know. For example, max 30, 40, so the maximum of 30 and 40 is 40, and the maximum of 30 and 40 is 30. Also, the maximum of 30 and 30 is 30, and the minimum of 30 and 30 is 30. So, determine the number of ordered pairs xy that satisfy the equation max 60 min xy, so the maximum between 60 and the minimum of xy, and the minimum between the maximum of 60 and x and y, we want those to be equal. Where x and y are positive integers with x less than or equal to 100 and y less than or equal to 100. Okay. So where to begin? This 60 number, I wonder if it's chosen arbitrarily or if it might be important. There's not a whole lot of manipulating we can do with equations when they're max and mins. Max and min are not, they're not polynomials, so you can't really algebraically manipulate them. But what we can do is we can say, okay, 60, that's a special number. Is x bigger than 60? Is x less than 60? Is y between x and 60? We can get various cases. Let's see if we can brainstorm how many cases we can have. And then we can sort of go through those cases and see what values of x and y do what things. So, what can we have? There's going to be 6 ways to arrange these numbers. That's just 3 factorial. Now we don't know if any of these are equal to 60, so we're going to have to put less than or equal signs there. So we could have x less than or equal to y less than or equal to 60. We can have x less than or equal to 60, but 60 less than or equal to y. What else can we have? We can have y less than or equal to x less than or equal to 60. We can have y less than or equal to 60 less than or equal to x. Remember, x and y, they are distinct because we're asked for ordered pairs x and y. And I believe the equation we're given is not symmetric in x and y. And so finally we can have 60, and then x and y are both greater than it. So these are the possibilities, and knowing what these are, we can try and see which equations are satisfied and when. Okay. So what's our equation again? Max 60 min xy, min max 60xy. Alright, so 60x and y are always written in order, and we just have max and min written about them. So, max 60 min xy. And so we can figure out what that is, and then we can figure out the opposite, the other side. So I'm pretty sure that was it, but we just double check. I don't want to write a whole bunch of stuff out. Max 60 min xy, min max 60 xy. Okay. So what we can do is, for each of these 6 cases, we can figure out, so like case 1, the min of x and y is going to be x. And then the max of 60 and x is going to be 60. So if for the first case, this first equation, this first formula works out to be 60. Does this bottom one also work out to be 60? We can have a little chart. Okay. So we're probably gonna have to do a lot more writing, but max 60 min xy. So that first thing, and then min max 60 xy. Alright, and then we have the first case, which was 60 greater than y greater than x. Greater than or equal to, sorry. And then we have we have y at the top. Y 60x, and then we have what was next? Y x 60, y 60x. Oh, I hope I don't run out of room. I should be fine. And then the last two we get 60s on the bottom. X and y, y and x. So these are increasing. So let's look at these. So for this first case, the min of x and y is going to be x. The max of 60 and x is going to be 60. Okay. The max of 60 and x is 60, and the min of 60 and y is going to be y. So for these two to work, we would need y is 60, and x can be whatever as long as it's less than or equal to 60. All right, how about this one? The min of x and y, well, that's going to be x. And the max of x and 60, that's still going to be 60. The max of 60 and x in this case is going to be 60, and the min of 60 and y is also going to be 60. So as long as x is less than or equal to 60 and y is greater than or equal to 60, this case works. So here we need y is equal to 60. This one's fine. How about this next one? Min of x and y is y. Max of y and 60 is 60. I'm noticing a pattern. 60 seems to be coming up a lot. How about this one? The max, we do the inner operation first. The max of 60 and x is 60, and the min of y and 60 is y. So once again, we need y less than y equals 60. All right, this one, the min is y, and then we maximize to 60. And this one, we get x, and the minimum of x and y is y, so we still need y is 60. Okay, and here we go again. The min of x and y is x. The max of x and 60 is x. The max of 60 and x is x. The min of x and y is x. So this one's good to go. And this last case, the min of x and y is y. The max there with 60 is y. The max of 60 and x is x, because he's all the way up at the top. And then the minimum with that and y is also y. So this one's also good to go. So what can we say? Well, these two cases, x and y, were greater than or equal to 60. So actually, let's go case by case. So in the first case, what did we need? So it implies y must be equal to 60. But then x can be anything we want, as long as x is less than y, which is 60. So there we go. That's a nice one. Second case. And if we were not confident, we could check. We could say let x be 32 and see if that works. So all the ordered pairs x and y with x less than or equal to 60 less than or equal to y work. They satisfy this equation. What exactly are we asked? Are we asked to list them all, or are we asked to count them all? Determine the number of ordered pairs. Okay, so this will be a little more challenging, but let's continue on listing out all the possibilities. So for the second one, we still need y is equal to 60, but this time x is greater than or equal to y. So the third case, the only thing that'll work is 60-60. Notice that 60-60 also works in the first case and the second case, so we are double counting things, which is why they're asking for the total number. So the fourth case, we need, it implies y equals 60. But other than that, it's okay. Everything else will be fine. So x 60 with x greater than or equal to 60. So the fifth case, that was fine. So really any x and y with 60 less than or equal to x less than or equal to y. And the sixth case is the exact same thing. So, how do these things overlap? It looks like every single set of cases overlaps exactly at 60-60. So the only ordered pair countered multiple times is 60-60. Alright, so if we were to eliminate 60-60, we wouldn't be double counting, we could just count how many things in each case. Okay. So that's one, and then we want these to be positive integers. So x can be between 1 and 59. So that's 59 cases. So the second case, I'm going to be doing a lot of flipping back and forth. I do apologize for that. So this one, in order to not double count it, I guess I should rearrange that. It should be counted most times. If we let y equal 60 and have x be less than or equal to, or less than 60, we'll be counting everything that was in the first case. So we don't want to do that. So we want x and y with x less than 60 less than y. And that's 59 possibilities for x times, I think it's up to 100 inclusive, so that would be 40 cases for y, right? Yeah. All right, so let's simplify that now while we've got it up. So 59 times 40, 2360. A thought just occurred, you could probably maybe graph this in some interesting way. Oh well. The third case, was that the one that just turned out to be 6060? Yeah, so the third case was 6060. The fourth case is y is 60, x will have to be strictly greater than 60 so that we don't double count the 61. So we'll count the third case by itself as the one instance where 6060 is done. That's 1. Was it 60x or 60y? It doesn't really matter. I just want to keep my notes consistent for anyone reading them in the future. So it is x. So that's going to be 40 cases. So from 61 all the way up to 100. So we're looking at 59 plus 1, that's 60, plus 40, that's 100, plus 2360, so that's 2460. We're not done yet, but just keeping a track in our heads. Now the fifth and sixth cases, they only differ in their ordering of x and y. So we can combine them. I don't know why that bracket's there. So fifth and sixth case basically just say x and y have to both be greater than or equal to 60, but we've covered all the cases where one of them's equal to 60 and the other one isn't. Or have we? Here we've counted this case, so the first one equal to 60. Actually, that should be rearranged. It's x is 60. And 60y, y greater than 60. So those are the two cases we have left. So that's 40 times 40. Well, these weren't cases. The fifth and sixth case basically tell us everything above or equal to 60 is fair game for both of them. And so we can split that into, they're both strictly greater than 60. Down here we have 60-60, that's already covered. And we already have the case covered where y is equal to 60. So the only other special case is x specifically equal to 60. So that's 40 times 40 for the first one, and 40 cases for the other one. And so now all we need to do is add all these up. So 2360 plus 59 plus 1 plus 60, or sorry, plus 40. And then these last cases, another 40. And then add on 1600, we get 4100. So I would say that's probably one of the roughest presentations of a problem I've given so far. very haphazard. You sort of have to watch the video and listen to what I'm saying. I didn't write down a whole lot of my descriptions. And so I could easily see, given the less methodical nature of what I did, I mean, I was very methodical up here, but when combining cases, I sort of fell apart. I could easily see myself being wrong there. I don't think I am. I think I've covered everything nice and neat. As I said, you could probably graph this, and that might help you better organize your thoughts. But I'm not going to go ahead and do that. So, not really a whole lot else to say. If I'm wrong, but I don't think I am. If I am, I might come back and do this video along with a very lengthy apology, but I should be fine. So that concludes question number 6. We're sort of flying by the seat of our pants, not explaining a whole lot. We don't need to. It's still part A. Part B, what I just did would not fly. We would need to actually explain what we're doing as we were going. But that concludes part A of the 2013 paper, and get ready, because part B is going to knock your socks off, but we'll have to wait for that in the next video. So thank you so much for watching. I'll see you all next time.